Today, we explore the fascinating life and work of an ancient thinker whose ideas continue to reverberate through the corridors of science and philosophy, Eudoxus of Cnidus. Eudoxus was a remarkable polymath of ancient Greece whose contributions spanned astronomy, mathematics, medicine, and even ethical thought. Although none of his own writings remain, his innovative ideas have been preserved through generations, inspiring some of the greatest minds that followed him. In this presentation, we journey into the world of Eudoxus, uncovering his life story, his groundbreaking theories, and the lasting legacy he left behind. Born around 390 BC in a coastal city of Anatolia known as Cnidus, Eudoxus nurtured an insatiable curiosity from a young age. His quest for knowledge led him far beyond his hometown, as he traveled to renowned centers of learning, such as Athens and Egypt. This adventurous spirit fueled his intellectual growth and helped shape his future contributions. Influenced by celebrated teachers like Archytas and Plato, Eudoxus absorbed a wealth of ideas from various fields, later weaving them into innovative frameworks that challenged the accepted wisdom of his era. With a creative and refreshing perspective, Eudoxus developed mathematical models to explain the motions of the heavens and formulated theories that continue to resonate in modern lectures and writings. His ability to blend careful observation with philosophical insight makes his work accessible even for those not steeped in technical details. As we delve into his journey, contributions to mathematics and astronomy, and his thoughts on ethics, we invite you to experience the lasting impact of a man whose ideas bridged ancient thought and future insights. Inspire boundless lifelong wonder. Delving deeper into the life of Eudoxus, we uncover a journey filled with intrigue, adventure, and relentless pursuit of knowledge. Born as the son of Aeschines in the vibrant city of Cnidus, located on the southwestern coast of Anatolia, his very name meant of good repute. This name, Eudoxus, reflected the promise of honor and intellectual integrity that he would come to embody throughout his life. Even as a child, his thirst for learning set him apart from his peers, and his destiny seemed intertwined with great discoveries. Eudoxus's early education was enriched by his time with acclaimed teachers, most notably Archytas, a pioneer of Pythagorean thought, and the writings and teachings of Plato. With Archytas, he absorbed mathematical rigor and geometric beauty. With Plato, he encountered philosophical debates that would later challenge and refine his own ideas. At the age of 23, seeking further enlightenment, Eudoxus embarked on a journey that would take him to the bustling streets of Athens. There he mingled with philosophers and sophists, absorbing diverse schools of thought that broadened his intellectual horizons. Not content with the boundaries of Greece alone, Eudoxus ventured further to Heliopolis in Egypt, a land renowned for its wisdom and ancient astronomical observations. Spending over a year immersed in the culture and scientific practices of Egypt, he gathered insights that would later influence his groundbreaking models of the cosmos. His travels did not stop there. Eudoxus journeyed northward to Cyzicus, and even made his way south to the court of Mausolus, engaging with scholars and dignitaries whose conversations enriched his understanding of the natural world. Upon returning to Athens around 368 BC, Eudoxus did not simply pass on his accumulated knowledge quietly. Instead, he assumed a leadership role within the academy during Plato's absence, mentoring students and advocating for a seamless blend of observational science with philosophical inquiry. Later, back in his native Cnidus, he served in the city assembly, built an observatory, and remained an active lecturer on theology, astronomy, and meteorology, leaving an indelible mark on both the scientific and civic life of his community. Throughout his travels and academic pursuits, Eudoxus remained undeterred by challenges. His relentless drive and humble demeanor earned him respect among peers and mentors alike, as well as admiration from those who later came to study his work. Many recount that his vibrant discussions and willingness to question established norms sparked lively debates among scholars. His life stands as a testament to the power of curiosity, determination, and the melding of diverse traditions in the pursuit of deeper truths. His legacy continues to inspire inquisitive minds. Eudoxus's pioneering work in mathematics stands as a monumental contribution to the way we understand numbers, geometry, and proportion. At a time when ideas of incommensurability and irrational numbers were beginning to unsettle the Pythagorean belief that all quantities could be expressed as ratios of whole numbers, Eudoxus introduced the concept of non-quantified magnitudes. This innovative approach allowed him to express the relationships between continuous quantities, such as lines, areas, and volumes, without being limited by the constraints of integer ratios. One of his most influential achievements was the development of the method of exhaustion, an early form of integration that allowed mathematicians to find areas and volumes by approaching them as the limits of increasingly accurate approximations. This method, which would later be celebrated and expanded upon by Archimedes, provided a powerful tool for analyzing shapes that could not be easily measured using simple formulas. By carefully inscribing and circumscribing figures, Eudoxus was able to pin down exact relationships, creating a bridge between the finite and the infinite. Perhaps the most celebrated aspect of Eudoxus's mathematical legacy is his elegant treatment of proportions and ratios. At a time when mathematicians struggled with the perplexing nature of numbers that could not be neatly divided, he introduced a method to compare ratios in a way that transcended the limitations of numerical measurement. His formulation, later immortalized in Euclid's Elements, defines when two ratios are considered equal through a systematic approach that involved taking any multiples of the involved magnitudes. Eudoxus's insights reached far beyond theoretical musings. By addressing the challenges of irrational numbers with his concept of non-quantified magnitudes, he allowed future mathematicians to consider geometric figures and spaces as continuous entities. This shift in perspective marked a significant departure from the emphasis on discrete numerical quantities that had dominated earlier schools of thought. His work laid the conceptual foundations for later intellectual revolutions, influencing not only his immediate successors like Euclid, but also future generations who would eventually lead to the development of calculus and real number theory. Eudoxus' revolutionary ideas also marked a turning point in mathematical thinking by shifting the focus from mere counting and numerical approximations to a deeper exploration of spatial and geometric relationships. His method of handling proportions, encapsulated in what would later become Book V of Euclid's Elements, revolutionized not only the study of geometry but also provided a solid foundation for the emergence of mathematical analysis. In a time when the idea of infinity was both intriguing and perplexing, his careful balance between the finite and the infinite demonstrated that rigorous thought could overcome apparent paradoxes. Moreover, his legacy in mathematics serves as a beacon for creative thinking and intellectual bravery. Eudoxus taught the world that mathematical problems do not always have straightforward numeric answers, and that sometimes the most profound truths lie in the way we conceptualize space and form. His ideas inspired a gradual transformation in the methodology of mathematics, shifting from rigid arithmetic procedures to a more fluid approach that embraced both rigor and creativity. In modern classrooms, echoes of his methods remind us to approach problems with analytical precision and imaginative exploration. Eudoxus' astronomical models were as innovative as they were elegant, offering a new way to understand the movements of celestial bodies. In an era when the motions of the planets and stars were shrouded in mystery, he introduced the concept of concentric, rotating spheres. This ingenious construction allowed him to model the complex motions of heavenly objects in a systematic and harmonious manner. Rather than relying on erratic explanations, Eudoxus proposed that the heavens were composed of multiple transparent and nested spheres, each turning at a uniform rate. His models were not simply abstract ideas. They were based on meticulous observations and a deep commitment to understanding the natural world. Eudoxus assigned multiple spheres to each planet, including the Moon, the Sun, and the 5 visible planets: Mercury, Venus, Mars, Jupiter, and Saturn. For instance, his model for the Moon involved 3 spheres to explain its daily rising and setting, as well as its monthly journey through the zodiac, together with an additional twist to capture its varying latitude. A fascinating aspect of his astronomical models is their artistic quality. With a keen sense of symmetry and balance, Eudoxus painted a picture of the cosmos that was both mathematical and poetic. The orderly rotation of concentric spheres suggested a universe governed by harmony and precision, a concept that resonated deeply with the Greek ideals of beauty and proportion. His ideas transformed confusing patterns in the night sky into a coherent system, inviting observers to see more than random motion. They saw a grand cosmic dance choreographed by celestial mechanics. However, Eudoxus's models were not without criticism. One notable drawback was their inability to account for variations in the brightness of planets as viewed from Earth. Since the spheres were concentric and centered on the Earth, the distance between a planet and the Earth remained constant in his models, leaving no room for changes in apparent luminosity. This issue, highlighted by later astronomers, prompted the development of alternative models incorporating deference and epicycles. Despite this limitation, the impact of Eudoxus' work in laying the foundations for celestial mechanics remains undeniable. Overall, Eudoxus's astronomical contributions revolutionized the way the ancient world interpreted the cosmos. His models provided not only a mathematical framework for understanding celestial motions, but also a poetic vision that captured the imagination of his contemporaries and those who followed. By attempting to decipher the celestial code through a system of elegant spheres, he set the stage for centuries of astronomical inquiry. Today, as we gaze at the night sky, we can still appreciate the creative spark that ignited the quest for understanding our universe. Eudoxus' influence on astronomy is not only measured by the models he created, but also by the legacy he left for future astronomers. His work inspired later scholars to think critically about the mechanics of the heavens, encouraging them to seek models that better accounted for observable phenomena. Although his system was eventually refined and replaced by more complex theories, the elegance of his approach continues to be admired. In many ways, his creative model of the cosmos set the groundwork for a shift from mythological explanations to systematic, scientific reasoning about the universe. In addition to his work in the sciences, Eudoxus ventured into the realm of ethics, offering thoughtful reflections on the nature of happiness and the pursuit of pleasure. His ethical perspective, as later recorded by Aristotle, embraced the idea that pleasure is inherent in all human endeavors. Eudoxus believed that just as natural bodies seek balance in the physical world, humans too are drawn towards experiences that maximize joy and minimize pain. For him, pleasure was not merely a transient sensation, but a fundamental objective that enhanced the quality of life. Eudoxus argued that all actions, whether governed by reason or impulse, ultimately strive for the good, which he identified with pleasure. He maintained that even activities pursued for other ends become more desirable when accompanied by joy. This view formed an early foundation for hedonistic thought, where happiness is valued as the highest good. In his ethical reasoning, Eudoxus challenged his contemporaries to consider that life's ultimate purpose might be found in the enjoyment of simple, natural pleasures, rather than in the pursuit of abstract, unattainable ideals. Reflecting on the extraordinary contributions of Eudoxus, it is clear that his legacy extends far beyond the narrow confines of any single discipline. He not only crafted elegant models to explain the movements of the planets and provided a rigorous foundation for mathematical reasoning, but he also ventured into ethical inquiries that celebrated the pursuit of pleasure and happiness. His work serves as a reminder that the quest for knowledge is a multifaceted journey, one that weaves together observation, creativity, and philosophical insight. Eudoxus' innovative ideas continue to inspire modern thought, influencing the way we approach problems in both the natural sciences and the humanities. His method of exhaustion paved the way for integral calculus, while his treatment of proportions has shaped the way mathematicians understand continuity. In astronomy, his concentric spheres offered a framework that, despite its limitations, marked a significant step toward the systematic study of celestial mechanics. Moreover, his reflections on happiness remind us that science and philosophy are not isolated pursuits, but parts of a larger tapestry of human experience. As we conclude this exploration, we acknowledge that Eudoxus' work remains a vital link between the ancient world and modern scientific inquiry. His legacy is a tribute to the enduring power of curiosity and the creative spirit. May his example inspire us to pursue knowledge with vigor, to question boldly, and to find beauty in the intricate dance of the universe.